Hello. In this video, we want to look at how we can take a polar coordinate and switch to Cartesian coordinates. So remember, for Cartesian coordinates, we're given a point x, y, which means we have gone a distance of x on the x-axis and a distance of y on the y-axis. So this is our polar coordinate. And we could also, sorry, this is our Cartesian coordinate. This is what we've known before. We could also have a radius of r and an angle off of the x-axis or the polar axis. And talk about that same point by saying we have the radius r and the angle theta, and that is what's known as polar coordinates. And we want, since they're talking about the same point, we want to see if there's a way to switch back and forth. And there is. The first thing to note is the fact we have a right triangle here drawn out, where one leg of the triangle is x and one leg of the triangle is y. And the Pythagorean theorem tells us x squared plus y squared is equal to r squared. We also, since we have a triangle, have a bunch of triangle and a bunch of trig identities of sine and cosine and tangent, that if we're looking at this right triangle, cosine is adjacent over hypotenuse, x over r. Sine is opposite over hypotenuse, y over r. And tangent is opposite over adjacent, y over x. So we have all the trig identities because we have a right triangle. And with these equations, this gives us a way to convert back and forth. First, if we want to convert from our x, y coordinates into our r theta, we want to go from Cartesian to polar. We can use the equation that r is equal to plus or minus the square root of x squared plus y squared. And that tangent, theta, is equal to y over x. If we want to convert from the r theta, from polar to xy, or Cartesian coordinates, we will use the equations that x equals r cosine theta and y equals r sine theta, by taking these two equations and multiplying by r on both sides. So we have two sets of equations to convert back and forth. So we're going to look at some examples. Suppose we want to find the Cartesian coordinates of the point -5, 5 pi over 6. That means we have an r of -5 and a theta of 5 pi over 6. Want to just briefly plot that. 5 pi over 6 angle would be here. And then the negative radius will send us to having a point approximately in that fourth quadrant where I've highlighted. That is the general area of where this point is going to be. Using our conversions from polar to Cartesian, we're going to use the equations x equals r cosine theta and y equals r sine theta. R is -5 and theta is 5 pi over 6. We know that cosine of 5 pi over 6 is -√3 over 2. So this works out to be 5√3 over 2. And for -5 sine 5 pi over 6, sine of 5 pi over 6 is 1/2. So this works out to be 5 over 2, -5 over 2. Making our Cartesian point the point 5√3 over 2, comma, -5 over 2. And does that make sense with where we've plotted our polar coordinate? Yes. We have a positive x and a negative y. So our Cartesian point should land in the fourth quadrant, which is also where our polar coordinate landed. So it makes sense for these points to be the same. Now, if we wanted to go backwards, suppose we wanted to find the polar coordinate with r greater than 0 with the Cartesian coordinates -√3, comma, -2. Where this point is -2√3, comma, -2, I go negative in the x direction, negative in the y. The point is going to be somewhere in the third quadrant. We are going to use the equations to go from polar to Cartesian, that r is plus or minus the square root of x squared plus y squared, and tangent equals y over x. So r equals the square root. We have r greater than 0, so we're not looking at the negative form. So r equals the square root of -2√3 squared plus -2 squared, which is equal to square root of 12 plus 4, so the square root of 16, which equals 4. Our radius is 4. Arctangent, or sorry, we have the tangent of theta equals y over x. So tangent theta equals y over x equals -2 over -2√3. Or tangent theta equals 1 over √3, or we can also write this as √3 over 3. If we were to solve for theta using arctangent, what arctangent would give us is the point or the angle pi over 6. But arctangent only gives us values in the first and second quadrants. We want something in the third. So we can take this pi over 6 and add pi. And that will give us another angle that has the same tangent value. So we will get tangent, or we'll get the angle of 7 pi over 6, and tangent of 7 pi over 6 is root 3 over 3. So we have that our angle theta is 7 pi over 6. Remember, there's a lot of angles we could be using. It would be 7 pi over 6. It could be negative 5 pi over 6. We could have (19pi over 6). I'll just write out the different options there. And there's many more. However, it is standard to pick the angle that is between 0 and 2 pi. So the angle that's between 0 and 2 pi is the 7 pi over 6. So we're going to pick the angle to be the 7 pi over 6. We have that the radius is 4. So that means that our polar coordinate is 4, 7 pi over 6. Finding the polar coordinates with r less than 0, we saw in the first video that r theta is equal to negative r, theta plus pi, or negative r, theta minus pi. So taking this coordinate we had before, 4, 7 pi over 6, if I make the radius negative, I can subtract pi and get negative 4, pi over 6, giving the same coordinate. So there is our polar coordinate with r less than 0, where 4 pi over 6 and negative 4 pi over 6 are equal to each other.